Welcome back. Today we're going to be learning about the dot product. Now the dot product is sometimes what we call the scalar product because we don't get a vector. Because if we multiply two vectors together, we're going to get a single scalar. Now where a vector gives us magnitude and direction, a scalar just gives us a number that has applications, of course, in the science world. So here's how we get the dot product. It's pretty easy. If we let vector A be defined as A1, A2, and B be B1, B2, then the dot product is defined as the product of A1, B1 plus A2, B2. So it's real simple. So we have a couple vectors here. We want to find the dot product. It's called the dot product. You'll see a big dot there of u and v. So we're going to take the dot product of u, which we're told is 2, 4, dotted with v, which is 3, negative 1. Well, our rule is to take the 2 times the 3 plus the 4 times the negative 1. And I can combine those. I get 6 minus 4, which is negative 2. Now the question is this a scalar or a vector? Well, this is a scalar. Easy breezy. All right. Question 2 says take multiply this one, so we got 3 times u and v. Now we already got u dotted with v. So this is just 3 times this negative 2. And that, of course, is just negative 6. No need to reinvent the wheel. We already have it, right? All right, now, try number 3. We're going to take vector w, dotted with vector v. But you got to be careful. W, remember, we're going to write this as 3, 4. And that's another way to write vector w. So if we want to dot it, we're going to take this 3, 4, and dot it with v, which is 3, negative 1. Make sure you put a big dot there. And our rule, of course, says to multiply those together. 3 times 3 plus 4 times negative 1. And that's going to give us 9 minus 4, which is 5. And, of course, again, that's a scalar. All right, let's try number 4. Number 4 says take the dot product of u and v, which we already have from up here, which we know is negative 2. And we're going to multiply that by vector w. And that's going to take negative 2, multiply that. Now you can put it in its component form, or you can leave it like it normally is, like it was, 3 plus 4j, and then distribute negative 6i minus 8j. Now, be careful, I took is this a scalar or a vector? Yeah, this is a vector. If you take a scalar and you multiply it by a vector, you will get a vector in return. So pretty easy to do. All right. Try number 4. U and v. Ooh, a little bit different. U dotted with v. U. So we're going to take the square root of 3, square root of x, dot that with the square root of 2, square root of 6. And just simplify. Multiply those two together. The square root of 3 times the square root of 2 plus the square root of 6 times the square root of 6. That's not bad. We get the square root of 6 plus 6. Not much you can do to simplify that, so we just leave it alone. By the way, be very careful. Scalar or vector? It's a scalar. It's a scalar. That is a number. There's no u, there's no I, there's no j. It's just a scalar. It's a number. All right. Now, one of the most useless rules in all of mathematics is the dot product can give us the magnitude. Because if you kind of think about it, we dot it with it. It's telling me to dot it by itself. So if I dot this by itself, 2, negative 4, dotted with 2, negative 4, well, what do I get? I get 4, 2 times 2, plus negative 4 times negative 4, which is 4 plus 16, which is 20. So there is my dot product. Well, my rule to find magnitude, to find the magnitude, is to just take the square root of that 20. Well, if you think about magnitude, again, remember this is just a vector, right? It's just a squared plus b squared equals the magnitude squared. That's right here. Most useless rule. You don't have to know this rule. If you know how to find magnitude using Pythagorean theorem, you're fine. Just use that one. But you might see some things on the paper like this in your homework tonight. All right, so now, why do we need dot product? Well, if I wanted to find the angle of one angle given a vector, right? if I want to find the angle, we would use the tangent, the inverse tangent of our change in x over our change in y. Other way around, change in y over change in x. But what if we have two vectors? The dot product can be used for that, and this is what we're going to talk about today. What if we have two vectors, a vector v and a vector u, and we want to find the angle between them? Well, we use dot product to get that, and that's down here right below. Okay, so here's our rule. So to find the angle between two non-zero vectors, we're going to use the inverse cosine of the dot product of AB times the magnitude of A and B. And that's what we're going to take a look at right here for like number 1. Find the angle for in between. So you'll need a calculator for this one. Make sure you're in the right mode. Second plus 712. Clear everything out. Make sure you're in the right mode. We want to be in degree mode. Degree mode. There we go. There we have it. All right. Now, next, find the dot product. So find the angle. Theta equals the inverse cosine of the dot product of negative 2, 5, 4, 1, 4 over the magnitude of negative 2, 5 times the magnitude of 1, 4. How's that? Doesn't that look kind of freaky? Don't worry, it's not too bad. We get the inverse cosine. Well, I got to get the dot product. Okay? Well, this just is just negative 2. Negative 2 times 1, that's negative 2, plus 5 times 4, which is 20, over the magnitude. That's just the square root of 4 plus 25, so that's 29, times the square root of 1 plus 16, 17. I'll go a little bit slower on the next one. So I'm going to get the second cosine of 18 over the square root of 29 times the square root of 17. And I just typed that in my calculator. That's second cosine, 18 divided by, now be very careful. Okay, a best way to write this one is to go 18 divided by the square root of 29, and I'm going to divide again by the square root of 17. Close parentheses, hit enter, and we get about 35.838 degrees. So you get 35.838 degrees, and that's the angle between the two. All right, so for part B, let's try B here. Okay, a little bit easier for us, this one. We know it's going to be the inverse cosine of A dot with B, or in this case, U dot with V, over the magnitude of vector U times the magnitude of vector V. Okay? So let's go do our side work over here. Remember, if you want to, this is 2, negative 3. This is 1, negative 2. To get the dot product, U, V, this is going to equal 2 times 1, 2, plus negative 3 times negative 2, which is a plus 6, we get 8. To get the magnitude of U, that's the square root of, be careful, 4 plus 9. We're squaring them, so we get the square root of 13. Get the magnitude of V, it's the square root of 1 plus 4, which is the square root of 5. So if I just plug everything in here, we get 8 on top over the square root of 13 times the square root of 5. Now you can simplify this a little bit if you want to make it easier. This is the square root of 18 over, the square root, 8 over the square root of 65. And you can just type that in your calculator. Might be a little bit easier. So second cosine, 8 divided by the square root of 65. Hit enter. 7.125 degrees. So very small one. All right, very easy to do. And you can kind of verify these if you want to, like if you kind of graph this. Over 2, 1, 2, down 3, 1, 2, 3. So there's this vector. Over 1, down 2. So as you can kind of tell, this angle between them is not very big, only about 7 degrees. Okay, now I'm going to start this one, may not be able to finish it because of this time and everything. I want to find a triangle is formed by these points, and I want to find the interior angles of each triangle. So to set this one up here, we're going to go -3, -4, 1, up 7, and 8, up 2. And I have a triangle. Okay? And we're going to call this A, B, and C. Okay? So if I want to find angle A here, per se, I need the magnitude of AB, which we'll call vector little c, vector little b, vector little a. So I need to find the inverse cosine of, ready, if I want to find this one, the angle in between for angle A, it's going to be the angle in between them, the dot product of C times B over the magnitude of C times the magnitude of B. That's not a G, it's a C. So I'm going to go and do this one with you guys. So if I want to get vector C, we have to get vector C. I look at what's happening. Vector C, I'm going from -3 to 1, so I'm increasing it by 4, and I'm going from -4 to 7, so up 11. Vector B says I'm going from -3 to 8. That's a change of 11, and I'm going up from -4 to 2, and that's a change of 6. So their dot product, C dotted with B, is just going to be 4 times 11, which is 44, plus 66, which is 110. The magnitude of vector C is the square root of, be careful, that's 16 plus 121, which is the square root of 137. The magnitude of B is the square root of 121 plus 36, which is the square root of 157. So I plug all of those in. Okay, 110. Now what I'm going to do is I'm going to multiply those together. It's a big number, I know, but it's not that bad to work with. What's 137 times 157? It's 20, the square root of 21,509. And the reason I do that, just to make it easier to type in. So if I type this in, second cosine, we get 110 divided by the square root of 21,509. And we get 41.41 degrees. And there we have it. 41.41 degrees. And I know what you're thinking, since we can find these distances right here, we could even use law of cosines and law of sines, okay? Then that's fine too. We'll talk more about that tomorrow. So go to part 2, we'll go on and finish up a few more of these, okay? Thank you.